So in this video, I'll try to illustrate the type of switches that we need to think about as a network engineer for a given use case. Generally speaking, you would be looking at switches and determine where the switch is going to fit in. So let's talk about what are some of the things that we need to look for in a switch. Generally speaking, when we are talking about switches, there are campus switches that are not data center. Campus is office building, office space, anywhere other than data center is campus switch. And then the major other category is data center switch. So you got two major categories, and that's how most of these switches are designed based on where they would fit in. Are they going in campus or are they going in data center? After that, the major difference is, okay, are they going to be layer 2 or are they going to be layer 3? So this is true for campus as well as data center. Layer 2 is most applicable on access layers where your users are going to be connected. And then from all of those layer 2, so if I have to draw this real quickly, you've got layer 2 switches on each floor of the building, right? And you got multiple buildings like these, and they all go aggregate on an L3 switch. So you have a topology per building like this. So this is one building, and then you have other buildings that would have similar topologies. So the users are connected here, your phones, IP phones, your APs, and what have you. So these L2 do not have routing features. They're very limited from a feature set point. And then the L3 will have the routing, where the routing features like OSPF is typically supported. Same is the case with data center. When you have L2 switches, you will have applications connecting to L2. So if I have to draw this, you have L2, L2, and you have apps and servers. Connecting to these L2, and then they go into an L3 core switch for the data center where routing is taking place. Could be OSPF, could be BGP. Most likely the data center L3 would have a lot more L3 capabilities than a campus L3. So there is one major difference. Again, the switches could be fixed. So if I have to put, they could be fixed. 1 RU, 2 RU, depending on number of ports you need, from 24 port fixed, 36 port fixed, 48 port fixed, to a chassis based, right? You have chassis based where you have a big chassis where you put in the supervisor called soup, and then you put in the line cards depending on number of ports you need. So this is chassis based. The 1 RU, 2 RU fixed switches are pretty much looking like this. Same is the case with the data center, depending on what is the scale at which you want to connect to. you would have an L2, which is typically called the top of the rack switch that goes, if you have these racks in your data center, you would put these switches on the top of the rack. These are typically fixed switches. And then your servers that are sitting here connect to the top of the rack. And these top of the rack switches in turn go connect to a network rack which has the L3 switch. So these are all L2. And these are typically copper switches. Doesn't have to be, it could be an SFP based. So they go and connect to the L3 switch, which is the network rack that has the firewall, load balancer, and what have you. And it maybe even a router. And again, these top of the racks are typically fixed. And in the network rack, you would have something like a chassis based switch that would get the number of ports, connect the firewall. So if you have L3 switch, you got the firewall sitting here, load balancer, router, what have you, right? So now you got these L2 and L3s with fixed and also chassis based. The other thing that you got to take in account for when you're choosing a switch, depending where it is, most of the time in campus you will have copper switches with SFP based uplinks. So these uplinks here, these are all copper connecting to the user, right? The cable is copper, UTP, Cat5, Cat6. But this cable right here would be fiber. Doesn't have to be, but typically the ports are SFPs, small factor pluggable, which could be copper, converted into copper / into a fiber, either multi-mode or single mode, depending on the distance of this cable or the distance between the layer 2 and layer 3. So this uplinks are typically higher bandwidth, 10 gig. These are typically copper 1 gig. So 10 gig fiber, multi-mode, single mode, uplinks right here. Same is the case here. These are copper, and then your uplinks are going to be SFP based multi-mode or single mode fiber. Now with the campus, the biggest thing that you also need to determine is for APs, which is the Wi-Fi access point or IP phone, they are powered. And sometimes cameras, if you're in an industrial situation or use case, these are powered. These are powered by Ethernet. And therefore, they're called power over Ethernet. So the campus switches would have PoE capabilities that you need to account for. How many ports PoE that you require. Now, data center does not or should not have PoE capabilities, or does not require, because they don't have any phones, users, APs, cameras. But if there is, then you'd have to put in a copper with a PoE capability. But typically in the data center, most of the switches are either copper or SFP, and that's about it. The PoE is a very campus specific feature set. So we got the features from layer 2, layer 3 fixed, number of ports, chassis, copper, and power over Ethernet, and also the uplinks would be SFP based, which is a small factor pluggable. These are either copper, you can put in a pluggable that could be copper or fiber. If it's a fiber, then it's going to be either multi-mode or single mode. Single mode has long ranges, and multi-mode has shorter ranges. It all depends how you want. These are cheaper, these are more costly. But anyway, depends on your distance and use cases. So that's the major difference between campus and data center switches. Now, in the data center side, when you have a switch, or even on the campus side, you have these ports, whether it's fixed or chassis based. Now, each port would have an ASIC. So let's see if I can draw an ASIC. That is going to be dedicated to a port. So here now you have an ASIC and a port, and the oversubscription is 1:1. Each port has an ASIC, a chip, a 10 gig each chip, or a 1 gig each chip, whatever the switch is. So your oversubscription here for data center would be 1:1. In the campus switch, on the other hand, your oversubscription is going to be higher. So each port, like 4 of them, would have one ASIC, 10 gig ASIC, shared between them, and therefore your oversubscription is most likely going to be 1:4, because you don't need line rate. This is more like a line rate. These are the terms that as a network engineer you got to understand and look for when you're choosing a switch. You need a line rate switch for applications, and so each ASIC here is dedicated to a port, and then obviously the uplink ASIC would be much more. So if these are 10 gig ports, this was going to be 40 gig / 100 gig, and multiple ports like this, and then you can port channel it, bundle it to increase your bandwidth. But your oversubscription from coming in to going uplink is also one of the factors that you're gonna have to look into besides the port oversubscription. So these are called line rate switches, and you don't need line rate switches on campus because the bandwidth, the traffic is not coming into the users, it's usually going out of the user. On the data center side, the traffic is coming into the servers and applications, so you have to consider line rates, oversubscription ratios, and all that good stuff. Also, within the switches, you have something called, and I'm running out of space and I don't want to erase all this good stuff, high availability. So in high availability, you have switches that you can aggregate together logically as one switch. So you put these switches as one switch, and this is called virtual switching system, or you can even stack. The other way to do it is stack them. So you have switches that are in one stack like this. They are logically in one switch, but this is high availability feature that you got to look for most of the time. It could be true for campus / data center. Okay, now these are the major type of things that you have to consider. Obviously, if a use case is more specific, you would get into the discovery of that use case. For example, use case of ISSU, in-service software upgrade, usually applicable in data center, where when you upgrade the software on a layer 3 or layer 2 switch, the traffic is still flowing. So there, even though you're doing upgrades, the ISSU feature would keep the traffic flowing, and that's not many switches do support that, but it all depends on the use cases. So these are the main things, but major is obviously the PoE for the campus, line rate, oversubscription for the data center, copper versus SFP, uplinks. These are the things that you have to consider. The first question when you're looking for a switch is obviously whether it's a campus or data center, and determine if it's campus, you got to go and dig a little bit more. Stacking, copper, PoE, power requirements, L2, L3, how the design is going to look like, all of that good stuff. But I just wanted to put this high level detail of what a typical network engineer would have to look for when choosing a switch. Hope this helps.